Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Today lecture is about the chemical bonding. Outlines of today lecture include introduction to chemical bonding and its application. That why we want to study the chemical bonds. We will discuss the Lewis structure because the chemical bond depend upon the Lewis structure. So we will discuss the Lewis structure. In Lewis structure, we generally see that how many valence electron is present in an atom. Types of chemical bonding. We will discuss different types of chemical bondings. Ionic bonds, which is formed by the transfer of electron. Then we will discuss about the covalent bond, which is formed by the sharing of electron. And the covalent bonds are of different types. Some bonds are polar covalent bonds, some are non-polar covalent bond, some are single covalent bond, double covalent bond, and triple covalent bond. So we will discuss all these types of covalent bonds. In today's lecture, we will discuss about the ionic bond and covalent bonds, but here I am mentioning the other types of chemical bonding, which is coordinate covalent bond, in which both the electrons are donated by one of the atom. One is the donor and the other is the acceptor. Then we will discuss about the metallic bonding, and in last types of chemical bond is the hydrogen bonding. So today we will start the chemical bonding. Let's see what is chemical bond. A chemical bond is a permanent attraction between atoms, ions, or molecules. And when they interact with each other, they form different types of molecules or compounds. For example, we can see over here the hydrogen molecule in which two hydrogen atoms share their electron because hydrogen have only one electron in the valence shell. So each hydrogen share that one electron and make a hydrogen bond. So this hydrogen molecule is there is a force of attraction between these two hydrogen atoms to form a hydrogen molecule, and this hydrogen molecule is formed by the sharing of electron, the valence electron of the hydrogen atom. Here we can see another example of chemical bond, that is sodium chloride, and it is an ionic bond. We can see ions in this molecule. Sodium have plus ion while chlorine have negative ion. It's mean that the sodium in the outermost shell consists of only one electron, which can be transferred to the chlorine atom because chlorine have seven electron in the valence shell. So it gain one electron, it take one electron from the sodium atom and form an ionic bond. So these two atoms combine and form a chemical bond and a molecule. Similarly, we can see another molecule in which the magnesium combined with oxygen atom, and a magnesium contain two valence electrons, so it can easily donate the two electron to oxygen atom because oxygen have six electron in the outermost shell. So it gain the two electron and complete its octet and become stabilized. So in this case, also an ionic bond is formed. We can see over here another example of chemical bond, the chemical bond between ammonia and boron trifluoride. And we can see that in this case, both the electron is donated by the by one of the molecule, and that molecule is ammonia. So this type of bond is generally known as coordinate covalent bond. We can see over here another type of bonding between the water molecules, and that is the force of attraction between a hydrogen atom, which is covalently bonded to an oxygen atom, and that hydrogen is attracted by the lone pair of electron of another electronegative atom, that is oxygen. So this types of bond is known as hydrogen bonding. So in this molecule, we can see that the atoms or the molecules are bonded with each other. They have force of attraction between the atoms or ions or molecule, and closely combine with each other and form chemical bond. Here we can see the copper metallic bond, that the copper atom, we can see that the electron show like a sea of electron, and the positive charge attract all these electrons with each other. So it is an immense an electronic cloud of copper ion. So this types of bond is known as metallic bond. So we can see over here that the atoms or molecules attract each other by either by sharing of electron or by transfer of electron. So these why we want to study these chemical bonds. So it's necessary to know that why we want to study these chemical bonds. So we see here two pictures. One is salt and the other is sugar. And in both cases, we can see that in these molecules, the atoms are chemically bonded. For example, in salt, the sodium ion and the chloride ion chemically bonded to form salt, and in sugar, carbon, hydrogen, and oxygen chemically bonded to form the sugar molecule. So, the interaction that account for the association of atoms into molecules, ion, or crystal, are in other stable species make up the familiar substances of the everyday world. Everyday world means that we can use salt, we can use sugar, fats, protein. So all these things are made by the chemical bonding which we are using on daily basis. Beside this, one of the most important application of the chemical bond is that the oxygen molecule we breathe is a result of a chemical bond. The two atomic oxygen combine to produce a oxygen molecule, and it's very necessary for the survival of life because if oxygen is stopped only for a few minutes, the survival is difficult. The starch, the sugar, salt, protein, fats, all these things we consume in our diet, and all these result from the chemical bonded between the atoms or molecules and make this valuable compound which we are use on daily basis. So it's important to know about the chemical bonding. Beside these, there is another important application that various types of medicine we use for different types of curing is a result of chemical bonding between atoms. The different types of soaps form because of the chemical bonding we use on daily basis. The different types of toothpaste. It's also in these molecule the atoms and ions are combined through chemical bonding. So it's necessary to know that how the chemical bond is formed. So the chemical bond we can understand the chemical bond by understanding the Lewis structure of an atom. So Lewis dot diagram were early an attempt to describe the chemical bonding and are still widely used. So what is the Lewis structure? Lewis structure is actually the representation of the valence electron of an atom, and we can represent it by a simple dot around the element or the atom. For example, we can see over here the hydrogen atom. Hydrogen has one valence electron, so we can represent with hydrogen a dot. So it's mean that hydrogen can form only one bond. We can see over here the calcium. Calcium have two valence electron because it is an alkaline earth metal, and a two electron mean that it can make this whereas Lewis structure show that it contain two electrons. So it mean that calcium can make two bonds. Similarly, aluminum, we can see the Lewis structure of aluminum. Aluminum have three valence electron. It's mean that it can make three bonds. Carbon have four valence electron, and we can represent the Lewis structure by representing dots around the atom. So it means that carbon can make four chemical bonds. Now we can see over here the oxygen atom. Oxygen have six electrons, but in this six electron, only two electrons are unpaired, while the other four electrons are in pair. So the paired electron is generally not participating in the chemical bonding. Only the unpaired electron, which is unpaired, the two unpaired electron can make two chemical bonds. So oxygen make only two bonds. Chlorine has seven electrons, and every atom want to complete their octet. So it have one unpaired electron, so it can form a single bond. Now we can see the example of water molecule. In this case, we can see that hydrogen have one electron and oxygen have two unpaired electron. So the unpaired electron shared with the hydrogen electron and make a covalent bond by sharing of electron. So oxygen can make two chemical bond with hydrogen, two hydrogen atom and make a water molecule. Similarly, we can see over here the carbon atom that the carbon form four bond because it have four valence electrons. So the carbon, when combined with oxygen, oxygen have two unpaired electrons and carbon have four unpaired electrons. So in carbon dioxide molecule, it can form double bond with oxygen to produce carbon dioxide molecule. So this is the Lewis structure, which is the base to describe the chemical bond. That how many bonds an atom will form, it depends upon the valence electron. So let's start the first types of chemical bonding, and that is ionic bond. Ionic bond is generally formed by the transfer of one electron or more than one electron from one atom to another atom. And the atom which lose one or more electron become a cation, a positively charged ion, and the one which gain the electron become an anion or a negatively charged ion. For example, we can see over here the magnesium chloride molecule. Magnesium combined with chlorine to produce MgCl2. Now, the magnesium have two electron in its outermost shell because it is an alkaline earth metal, and the electron is shown with the purple empty balls. So, the magnesium give one electron to one chlorine atom to produce a chloride ion, and one electron to another chlorine atom to complete its octet and make the magnesium chloride molecule. And as this bond is formed by the transfer of electron, the magnesium transfer two electron, one electron to one chlorine atom and one electron to another chlorine atom to produce the MgCl2 molecule. Similarly, we can see over here another example of calcium oxide. Calcium is also an alkaline earth metal, and it have two electron in its outermost shell, and electron have six oxygen have six electron in its outermost shell. So the calcium donate two electron to the oxygen atom and become a calcium plus 2 ion and oxygen minus 2 ion produce the calcium oxide molecule. So these types of molecule which is formed by the transfer of electron from one atom to another atom are known as the ionic bond. An ionic bond is formed only when one of the atom is metal and the other is non-metal. So we can see over here that the magnesium is a metal while the chlorine is non-metal. Similarly, in calcium oxide molecule, we can see that calcium is metal and oxygen is non-metal. So generally the ionic bond is formed between a metal ion and another non-metal ion. The metal atom must have low ionization energy, and we can see that the alkali metal and alkaline earth metal have generally low ionization energy so that it can easily release the electron and form a cation, while the non-metal should have a high value of electron affinity to attract the electron to form an anion. So, generally, the ionic bond is formed by the transfer of electron from metal to non-metal. Now, what is the characteristic properties of ionic compounds? Due to the presence of strong forces of attraction between the cation and anion, ionic compounds are solid and are hard to break. For example, we can see that sodium chloride is hard. Similarly, calcium oxide is hard and solid form. So generally, all the ionic compounds are generally in solid state because of the strong force of attraction between the ions. Ionic compounds have high melting point. Ionic compounds are hard and brittle. We, we generally see that all the ionic compounds are generally brittle in nature, they are hard and they have high melting point. Ionic compound dissociate into ions when dissolved in water. For example, if we dissolve sodium chloride, the sodium ion and the chloride ion is formed. Solution of ionic compounds and melted ionic compound conduct electricity, but solid material do not. In solid state, the ionic compound do not conduct electricity, but when it is in molten state, it conducts electricity. The second type of bond is the covalent bond. As we see that in ionic bond, the bond is formed by the transfer of electron, but in covalent bonds, the covalent bond is formed by the sharing of electron and each atom equivalently share the electron. So to establish a covalent bond, the force of attraction between the atoms should be equivalent. It means that each atom equivalently share the electron. Both the atom ionization energy must be high in order per electron to be difficult to be removed. So, due to the strong ionization energy, the removal of electron is difficult. Therefore, they share the electron to form the covalent bond. For example, we can see over here that both the hydrogen atom have a single electron, so they want to stabilize. So it share both of the electron and form a covalent bond, hydrogen covalent bond. Similarly, we can see over here the chlorine-chlorine bond, and in chlorine-chlorine bond, both the atom have high ionization energy, so therefore it cannot be transferred that one of the chlorine atom take the electron. So it generally share both equally share one electron to produce a covalent bond. These types of covalent bond is known as non-polar covalent bond because every atom equally share the electron pair. Now we can see over here the water molecule. In water molecule, the hydrogen atom share its electron with the oxygen atom and form a hydrogen-oxygen covalent bond. And in this case, two hydrogen atom combine with one oxygen atom to produce the water molecule. And in this case, the oxygen complete its octet and the hydrogen its doublet and it's stabilized. So, as the bond is formed by the sharing of electron, therefore it is known as covalent bond. In the hydrogen molecule and water molecule, the shared pair of electron is equally attracted by the atoms and therefore it is known as non-polar covalent bond. But in water molecule, the oxygen is electronegative, therefore it's attract the shared pair of electron toward itself more tightly as compared to the hydrogen atom. Therefore, a partial negative charge on oxygen exists and a partial positive charge on both of the hydrogen exists. It's mean that it is a polar covalent bond because two different types of poles are produced in the water molecule, so it is a polar covalent bond. Now we can see over here the methane molecule. In methane molecule, the each hydrogen atom share an electron with the carbon atom. So carbon have four electron. It can form four covalent bond with the hydrogen atom and complete its octet to become stabilized. In this case, the covalent bond is considered as a covalent bond as the electronegativity difference is not much more. Therefore, the shared pair of electron is approximately equally shared by the carbon atom and the hydrogen atom. When non-metallic element such as chlorine and oxygen react with non-metallic element, they share electron in order to obtain 8 valence electron. As we can see over here, that in case of water molecule, the oxygen complete its octet. In case of carbon molecule, methane molecule, the carbon complete its octet. In case of chlorine molecule, both the chlorine atom complete its octet to become stabilized by sharing of electron. Now, covalent bonds are of different types. Single covalent bond, when a single pair of electron is shared by the atom, are known as single covalent bond, as we can see in the hydrogen molecule. The double covalent bond, in which two electron pairs are shared by the two atoms, are known as double covalent bond. And triple covalent bond, when three pair of electrons share with each other to complete its octet, then it is known as the triple covalent bond. For example, we can see over here the example of triple covalent bond nitrogen, the example of double covalent bond, we can see double covalent bond in carbon dioxide and single covalent bond in hydrogen molecule. Single bonds are formed by the sharing of one pair of valence electron, and they are generally less reactive, and they have high bond length and denoted by a single dash. The double bonds are formed by the sharing of two pairs of valence electron, and they are moderately reactive and have a moderate bond length and donated by the two parallel line. The single covalent bond have a bond length generally 154 picometer. The double bonds are generally 144 picometer, and the triple bond are very short, and it's approximately 134 picometer. The triple bonds are formed by the sharing of three pairs of valence electron. They are highly reactive and have a low bond length as compared to the double bond and as compared to the single bond, and they are denoted by three parallel lines. Covalent bonds, on the basis of polarity, covalent bonds are divided into two types. One is known as polar covalent bond, and the other is known as non-polar covalent bond. As we can see over here in the water molecule, the shared pair of electron is attracted by the oxygen atom. Therefore, the oxygen have partially negative charge while the hydrogen have partially positive charge. So poles are produced in these molecules. Therefore, it is known as polar covalent bond. While in chlorine atom, as both the chlorine atom have same electronegativity, therefore the shared pair of electron is equally attracted by each chlorine atom. Therefore, this bond is known as non-polar covalent bond. A nonpolar molecule is a bond usually formed between two identical atoms, and they are the ideal example of covalent bond. Some examples are nitrogen gas and chlorine gas of the nonpolar covalent bond. For example, we can see over here the nitrogen molecule that the shared pair of electron is attracted by both the atom equally. In carbon dioxide molecule, oxygen have relatively electronegative as compared to carbon atom. So it is, but as the dipole moment is cancelled by each other, therefore the carbon dioxide molecule is also considered as a non-covalent bond. Similarly, the carbon tetrachloride, as the dipole moment is cancelled by each other, therefore this molecule is also known as non-polar covalent bond. The polar covalent bond is the process of unequal sharing of electron. It is considered the middle ground between ionic bonding and covalent bonding. It's happened due to the different electronegativity values of the two atoms. Because of the different electronegativity value, the more electronegative atom will attract the shear pair of electron stronger pulling force on the electron. Thus, the electron will spend more time around the most electronegative atom. For example, we can see over here the hydrochloric acid molecule. In this case, the shared pair of electron is attracted by the chlorine atom. Therefore, chlorine have partial negative charge and hydrogen have partial positive charge. So this is a polar covalent bond. In generally polar covalent bond, the shared pair of electron is attracted by the a more electronegative atom and produce a pole. Therefore, these types of bond is known as polar covalent bond. Similarly, in water molecule, we can see that oxygen have more electronegative atom as compared to hydrogen atom. Therefore, the shared pair of electron is attracted to oxygen more effectively as compared to hydrogen. So, oxygen have partial negative charge while hydrogen have partial positive charge. So, poles are producing. So, this type of chemical covalent bond is known as polar covalent bond. Similarly, in ammonia, we can see that nitrogen is more electronegative, so the shared pair of electron is attracted toward the nitrogen, and therefore this molecule bond is also known as polar covalent bond. So, characteristics of covalent bonds, the covalent compound exists as gases, liquids are soft, solid. We see in the ionic compound that ionic compounds are generally present in the solid form, and they are hard and have high melting point. But the covalent bond have variety. They can exist in gaseous form, in liquid form, or maybe in soft solid form. The melting and boiling point of covalent compounds are generally low as compared to ionic compound because they are soft, solid, or liquid, or in gaseous form. Therefore, they have low boiling and melting point as compared to ionic compound. The covalent bonds are directional, where the atoms that are bonded showcase specific orientation relative to one another because one of the atom attract the shared pair of electron more than other. Therefore, these covalent bonds are known as directional covalent bonds. The covalent compounds are generally soluble in non-polar solvent. They are insoluble in water as it is a polar solvent. The covalent compounds do not conduct electricity, as we see in the ionic compound. That the ionic compound in solid state do not conduct electricity, but in molten state they conduct electricity. But the covalent compound do not conduct electricity; they are not good conductor of electricity. This is because covalent compound do not have charged particle capable of transferring electron. So how we can decide that the covalent bond, that the given bond is polar, non-polar, or ionic bond? It's depend upon the electronegativity difference. If the difference in electronegativity is between 0 to 0.3, then the molecule is considered to be a non-polar polar bond. If the difference of electronegativity of bonded atom is between zero point 0.3 to 1.7, then the molecule is considered to be a polar covalent bond. But if the difference is 1.7 or more, then the molecule has an ionic bond. So in today's lecture, we discuss the chemical bonding, that what is chemical bonding? Chemical bonding is the force of attraction between atoms, ions, or molecule to produce different variable compounds. And then we describe that how we can describe the chemical bond. A chemical bond can be described on the basis of Lewis structure, that how many valence electrons are present with an atom, and the numbers of bond depend upon the valence electron. For example, hydrogen have one valence electron, so it can form only one bond. Calcium have two valence electrons, so it can form two bonds. Nitrogen have three valence electron, it can form three bonds. So the chemical bonding, the numbers of chemical bonding depending upon on the numbers of valence electron. And then we discuss that the chemical bonds are of different types. The ionic bond and the covalent bond we discuss in today's lectures, that ionic bonds are formed by the transfer of electron, while the covalent bond are formed by the sharing of electron. So in next lecture, inshallah, we will discuss the other types of chemical bonded, coordination covalent bond, metallic bond, and hydrogen bonding. Thank you.